The world is not so perfect, at least not as perfect as we assumed in the optimization model. And we might need to include some extra information and to explicitly address those features in some problem. So it might happen that task durations are very variable or are far away from being constant or deterministic, and we will see how to address that. Second, we assumed in the optimization model, that was an implicit assumption, that the buffer in between every two stations was infinite, but that might not be the case if we have some limited capacity for storing amplifiers in between every two stations. You can have blockages and shortages, and that might affect the overall performance of the line. You can have, of course, breakdowns, and repair time is the time during which you don't have access to that resource and you have less production than expected. Other times your supplier doesn't deliver the raw material in time or with the agreed upon quality, and that means that you don't have enough material to start assembling an amplifier, and that will affect as well the production rate. And finally, as another example, sometimes you need to reprocess things because after performing the tasks assigned to a station, you don't have the desired outcome, so you need to reprocess it, and that means losing some capacity of your line. These are just some examples of things that can happen that leads us away from the assumptions we had in our optimization model. I have these two in orange because these are the two we're going to explicitly incorporate within our model, in our simulation model. Although we could include this all, the thing is I just developed a model that includes these two features here, where we see the impact already of having this non-deterministic. So when it comes to task durations, what we have done is extending the information we had to include the variability. In this table we have all 12 tasks with this column mean, which is the value we assume to be deterministic in the optimization approach, 3 to 6, 7, all the way to 3 here. And we have included a third column with the variability, so that we assume that tasks durations are randomly distributed within an interval, which is 3 minus 10%, 20% of that 3, and 3 plus 20% of the mean. And the same goes for all the tasks. So, for example, for task 1, what we have is times distributed in the interval 2.4 to 3.6 minutes. So there is the source of variability. Of course, you might have other distributions, other ways of having variability. I'm just assuming this is the case for the sake of simplicity. You should perform an analysis of your data to represent how things are in a valid manner. But for exploring and highlighting how uncertainty works, that is good enough. So that is how durations of tasks are, but we need to measure the time of every amplifier in every station. So within the deterministic case, station 1 had these tasks assigned, so the time for an amplifier within that station is always 20. But now that varies, because now we have that the time for task 1, as we saw, varies between 2.4 to 3.6. The time for task 2 assigned to station 1 goes from 4.8 to 7.2, which is 6, with the corresponding variation of 20%, and the same goes for tasks 3 and 5. The result is that the time that an amplifier remains in each station differs, and we can have the effect of having some stations going faster than others and having some blockages. And the fact that we do not have any buffer in between stations will increase that effect. We'll see that when we use the simulation model in a minute.